Well, welcome back. Thanks to part 2 of our Quiz 103 help. We did this in class. Some of us, we understood the relationship like we used to compare with fractions right away. Others, we kind of struggled with this idea, and I take responsibility for that because I didn't have a clear way to guide you to compare, and I apologize, but thanks for watching. I since then have reached out. Some of you I will have had the meeting with Ashley by the time I teach you this. And Mrs. Matson, my mentor teacher and our other 6th grade math teacher, I met with her on Friday so that she could help me come up with a way that best makes sense in your mind when it comes to comparing whether fractions or ratios. So when they're strictly asking us to compare, is this greater than, less than, or equal to? Here's what we can do. It's called the butterfly method. We had a student in class also share it, and I asked about it, and it's wonderful. So there's one way we'd make a wing, and at the top part of the wing, we put a line there. We make another, well, it's fine. It can stay the same color. Put a wing and put a top part of the line there. So now we multiply. We're going to multiply the opposite numerator and denominator. We're going to end up with 9 times 9 is 81. 12 times 6 is 70, no, 2, 12, yeah, 72. 72. Now you can just compare these top numbers and you'll be able to see, okay, well, 72 is less than 81, called the butterfly method. And essentially what you're doing is you're creating an equivalent fraction, but you're just looking at the numerators because the denominators are going to be the same. Over here on this side, we're multiplying the top and the bottom by 12, and that would become 9 times 12, 90, 108, right, is the same denominator or equivalent ratio, and 9 times 12 over here. Does that make sense? If not, please send me an email, but we're going to move on. So that's the best way to compare. It's called the butterfly method. Thank you for sharing that with me, and thank you to Mrs. Matson for teaching me this. So that's the other video. Okay, so now when we talk about the plotting a coordinate plane to represent each of the ratio values, this is our ordered pair. We just take a look at time and distance and see where is it labeled. Here's time, here's distance. So when time is 1, distance is 3. So I go over 1. Oh, and we look at the scale. Look, these are each scale. And I go up 3. 1, 2, 3. Boop, there it is. 2 is 6, so time is on the x-axis. I go to 2, I go up to 6, and I find it. Time is 4. When time is 4, distance is 12. So I go over 4 and then up to 12. And when time is 6, I go over to 6 and then up to 18. Good job. Great work. All right, finally, where's the, oh, there it is. Okay, now this was the other one we worked together. We are trying to figure out what the missing numbers are to create equivalent ratios. What I would recommend doing is finding the simplest form. It looks like 8 and 2. Well, 2 is even, so I'm going to break this down the simplest form over here, number of servings, 4 to 1 liter of punch. Now that will help me figure out these equivalent ratios. Over here, I can take 4 to 1, and I'm going to put parentheses around it. I need it to be 4, so I'm going to multiply both sides by 4 because 1 times 4 is 4. So then this is going to be 4 times 4, 4 times 4 to create this equivalent ratio in the chart. Perfect. So again, the same ratio, 4 to 1. I'm going to look at the information they give us, 20. 20 is 5 times 4, so I'm going to do 5 times 4, 1 times 5, so I'm going to put 5. And then finally over here, 4 to 7, well, oops, 4 to 1, how do I make that 1 a 7? I'm going to multiply it by 7, multiply it by 7, and it should be 28. That's it for us. Thank you for watching. Please email if you have any questions.